In previous lecture, I already discussed introduction to sets, set representation like set builder method and roster method, then sets for number system, intervals like open interval, close interval and equality in sets. Next I will discuss empty set. If one set contains no element, then it's called as empty set. It also called as null set. We can say empty set or null set. It can be represented by phi or simply we can give the braces. So no element inside curly braces means this is null set or empty set, or simply we can write phi. If one set contains just one element, it's called as singleton set. Most people confuse between phi and this phi. This is one singleton set. This set contains a null set, and here this means null set or empty set. So don't confuse between these two. One is null set whereas one is singleton set. It contains one element and that element is phi or null set, or we can say empty set. Next is Venn diagram. We use a graphical representation for set that's called as Venn diagram, and it is named after the mathematician John Venn, who introduced their use in 1881. In Venn diagram, we will use a universal set U and it is represented by a rectangle. Within rectangle, we can use different graphical representation like circle or oval for this set, and within set we use dot to represent elements. So Venn diagram cleared the relationship between sets. Let's see one example. Example 6. Draw a Venn diagram that represents B, the set of vowel in English alphabet. So here universal set is English alphabet. So U will be that 26 alphabet, and from that our set B contain 5 alphabet like A, E, I, O, U. So here this rectangle is for universal set that contain our 26 alphabet, and within that this is our set B. B contain 5 alphabet like A, E, I, O, U. Here we represent each individual alphabet by a dot and set by a circle and universal set by a rectangle. Next is subset. A set A is called subset of B if all elements of A are present in B. Definition 3. This set A is a subset of B if and only if every element of A is also an element of B. So we use this notation for subset. How will show that A is subset of B? To show A is subset of B, we need to take one X such that if X belongs to A, then X belongs to B. X is an element that belongs to A, also X belongs to B, means A is a subset of B. So to show A is not subset of B, we need to find a single X such that X belongs to A and X not belongs to B. So we need to find a X, we need to find a element that belongs to A and that doesn't belongs to B. So you can say A is not subset of B. Let's see one example. Example 7. The set of all odd positive integer less than 10 are subset of set of all integer less than 10. So odd positive integer will be 1, 3, 5, 7, 9, and set of all integer will be 1, 2, 3 till 10. So this set of all odd positive integer less than 10 is subset of set of all integer less than 10. Like this, set of all rational number is subset of set of all real number. How will you represent subset in Venn diagram? Let A is subset of B, that we can represent like this. Here A is a subset of B. A is one set, all element of A are also in B. So A will be within B and there will be the universal set. Now theorem 1. For every set S, phi will be subset of S and that set itself will subset of that. We can say phi is subset of S and S is also subset of S. So how will prove that? For proving that phi is subset of S, we need to take one X such that x belongs to phi and x belongs to s. But there are no element that belongs to phi, as phi is a empty set. So x belongs to phi is always false. And I already discussed during proof that in case of implication, if left side is false, or you can say if hypothesis is false, then whatever the conclusion, it will be always true. So false implies true, it will be true. False implies false, it will be true. So if hypothesis is false, then it will be always true. X belongs to phi is false, that means x belongs to phi implies x belongs to s is always true, and a conditional statement with false hypothesis is always true. So therefore, for all x, x belongs to phi implies x belongs to s is true. Like this, you can prove the second part, and this is a type of vacuous proof. If hypothesis is false, then it will be always true. If A is not equals to B and A is subset of B, that called as A is a proper subset of B. For all x, x belongs to A implies x belongs to B, and there exists a x such that x belongs to B and x not belongs to A. Let's take an example. A contain 1, 2, 3, a simple example, and B contain 1, 2, 3, 4, 5. So you can say A is a subset of B. Right? A contain 1, 2, 3, B contain 1, 2, 3, 4, 5. But in B there are some elements like 4 and 5 which are not in A. So you can say A is a proper subset of B. A is not equals to B. All elements of A are present in B, but all elements of B are not present in A. To prove two sets are equal, we can consider if A is subset of B and B is subset of A, then two sets are equal, means A equals to B. A is subset of B and B is subset of A, means A equals to B. Let's take an example. We have a set A contains phi, then A, B, and B contain X is a subset of the set AB. So all subset of AB will be phi, then A, B and AB. These all things are present in A. So you can say A and B both are equal. Both are represented in different way. This is a roster method, this is a set builder method, but both contain the same element, that's why A equals to B. We can say A is subset of B and B is subset of A. And here mark that A doesn't belongs to A, even B doesn't belongs to A. A set belongs to A, but single A doesn't belongs to. So this set A contain all the subset of AB. This A and within bracket A both are different. This is a set while this is a single element. In today's lecture I discussed empty set, Venn diagram and subset. In next lecture I will discuss the size of set, or you can say cardinality of set. If today's lecture is helpful for you, please like, share and subscribe. Thank you.